Hello guys, this is Vivs here from Design Coder. In this video, let's talk about the wrap content attribute in a little more detail and layout weights in Android using the linear layout. So for the first step, in the previous video, I showed you what is a wrap content. In this video, let me show you why we need it. Here, I have my linear layout which is horizontal having two children. As you notice, the green box and the red box. Now if I give it a height of say 144 dp, you notice no difference here on the right hand side. If I give it a greater height, like say 192 dp, you immediately notice that the linear layout here takes up more space in terms of height and the other two boxes remain unchanged. But what happens if I give it a lesser height? So the height of a child here is 144 dp. If I go and make the linear layout just 108 dp in size, immediately you notice that things are cut off. In fact, if you highlight the item, you notice that it overlaps with the pink item below over here. Now this is the reason why you use wrap content instead of giving fixed heights to your linear layout. There's one more issue that wrap content tackles. Let me show you what I mean. Here, let's say the height of the linear layout is 144 dp. And now if the two children have different heights, let's say one of them is 144, the other one is 256. In this case, again, we see an overlap because the second child now exceeds the bounds. But if our linear layout had a height of wrap content, you don't have to worry about the size of the children at all because it would stretch every time the height of a child changed. Notice that here wrap content means find the largest child, its height, and ensure that the linear layout fits the largest child inside. This is how the wrap content actually works. Here again, if you go and make the first one taller than the second one by say 144, let's make that 288 dp. Notice that this time again the linear layout has changed to incorporate the green child inside it. Currently, whatever we see on the right hand side is a preview on Nexus 4. However, let's see how it looks on all the devices. So here we can select a different device, or we can say preview all screen sizes. So once you say preview all screen sizes, notice all the devices out there that are showing the same set of boxes. Notice how some of them are able to fit more space at the end compared to some of them. Notice this tablet here has a lot of space after the two boxes and this one here as well. I have restored the layout back to a simple vertical linear layout to understand the concept of weights. So right now on the Nexus 4 device, we are able to see all four blocks. Now if you go and change the device here to say Nexus S, notice that Nexus 4 is 4.7 inches whereas the Nexus S is smaller. Let's take that device and try to see what happens. Immediately you notice that the pink block here at the bottom is cut off the screen because we don't have enough space. If you go to a device which is even smaller than this, which would be the Nexus 1, which is 3.7 inches, notice that again we see a similar effect. What if you wanted all the four blocks to take up equal space on the screen regardless of the height of the screen? That is where weights come into picture. Weights are simply proportions which you indicate to Android saying that this view should take up this much proportion. Go to Google and type Android layout weight. Once you do that, you're taken to this link from developer.android.com. Be sure to read the section about the linear layout and especially about layout weight. So to say that all the four views will have an equal height, I will go here and say layout weight is 1 over there. I just need to copy paste that attribute everywhere to indicate that they are of equal importance here. Notice that the calculation for layout height that says 144 dp is not needed anymore, but we still need to define a layout height attribute. When you use a layout weight, Android will use that weight proportion to calculate your height. So if you also specify the height, then the height calculation is going to be done 2 times. So let's give it a weight of 0 dp to ensure that that doesn't happen. So you go there, give it a height of 0 dp everywhere. And now the heights of each of these views is based on their weight. Now if you go and take a look, they all appear to take equal space in terms of a vertical orientation. If you take another device here, say Nexus 5, you will still notice the same aspect. In fact, if you go and preview this on all the screen sizes, you will notice that the four blocks look exactly the same, taking equal amounts of space on all devices. Isn't that amazing? That is one way you can control how something should look same across all screen sizes. Now since we are using a vertical linear layout, the layout weight attribute is working on the height of each view object. But if we had a horizontal linear layout, then it is going to work on the width of each object. Notice that all the objects disappeared from the screen. That is because the height is 0 dp now. We need to go here and give it a height of 144 dp everywhere. Now the four items tend to be divided equally in terms of horizontal space. That means the width calculation that says 144 dp is redundant. In other words, it's going to be done twice. First, Android will see this layout weight attribute and it will see that your linear layout is horizontal and say, okay, so all the items must have equal proportion horizontally. That means the calculation for the width is redundant. So you can put 0 dp for the width everywhere and you would still get the same result. So now if you go and take a look, all the items appear to have equal width. So what if you want to give one of them more importance? In that case, you go and make the layout weight of the first item say 2. And immediately you notice that the first view here takes twice as much space as the others. Now the idea here is simple. Android is going to see the layout weight of this as 2 plus 1 3 plus 1 4 plus 1 5. So the first item is going to get 2 by 5 of all the available width. The rest of the items are going to get 1 by 5 of all the available width. Again, it's not compulsory that you have 1 here. You can put another 2 here, in which case the second and the first are both going to be twice as big, whereas the other 2 are just going to take 1 by 5th of the space. This time, if you try to sum up the weights, you get 2, 2, 4, 5 and 6. Now you can control the value of the sum as well. For that, you go to the linear layout at the top and you use this attribute called weight sum. So for the weight sum, I'll simply say 6 here and immediately you will notice that everything still looks the same. But if I use a weight sum of say 8, immediately you notice that here we have some extra space at the end because the sum of the total items is now expected to be at 8 and you added 2, 2, 4, 5, 6. So that means 2 of space is still empty over here to add something else. So this is how the weight sum works. But instead of increasing the weight sum, let's say you go in the opposite way and reduce it by saying 4 over here. Notice that the other 2 views are now off the screen. So the first view here has a weight of 2 and the next one has a weight of 2, which is 4, and that's exactly what is allowed inside your linear layout. The third view, if you try clicking on it, it's not there anywhere. If I change the weight sum back to 5 here, notice immediately that I have the cyan box appearing here. That is because 2 would be allowed and this one has a weight of 1, which means it will be allowed as well. If I go back and put 6 here, notice that all 4 views appear once again. So this is how weights and weight sum can be used. Now that you understand this, let's try something a bit more complex. So I have restored my layout from what we had earlier. That would be one horizontal linear layout containing the green and red box and another horizontal linear layout containing the blue and magenta box. Now our goal here is to divide the screen space equally among these 4 boxes. Let's take a look at how we can do that with layout weights. The highlighted area here on the right hand side is the first linear layout, which is horizontal, that contains 2 children, the green and the red box. So let's go to that linear layout, which would be right here. Now this is horizontal, so if we use a layout weight attribute on any of its children, it will only apply in terms of width. So let's go there and make a layout width of 1 over here. Once we add the layout weight of 1 for both children, remember that the width calculation is redundant. So we can give it a 0 dp for both children. You will immediately notice that the 2 red and green boxes here take up equal width on the screen. The same way, if you highlight this linear layout, it is also horizontal and contains 2 children, the cyan and the pink box. So let's give it the layout weight attribute to each of them and make their width 0 dp each, just like we did in the first one. So after we assign the weights, we are left with 4 boxes like these, where the first linear layout has equally divided horizontally and so is the second one. Now we need to divide this vertically in the same fashion. Let's see how we can do that. So our yellow box takes full width and full height, and notice that it has a vertical orientation. Now it has 2 children at the first level. That would be this linear layout, which is horizontal, and the other one, which is horizontal. So if we use a layout weight attribute, it is going to apply on the height of each linear layout because the root is vertical. So here in the first child, I'm going to go here and say layout weight equals to 1. Same thing I'm going to go and do to the other linear layout as well. Now remember that the height which says wrap content here is not important anymore because the height calculation is automatically done by the layout weight attribute. So we can remove this and say 0 dp for the first linear layout's height, and we can do the same thing for the second one as well. So now if you go and take a look at the preview here, the thing works because this linear layout and the other one which are contained inside our root linear layout are view groups, which in turn are views themselves. So you can use the layout weight attribute on them as well. So here, if you take a look, the first linear layout now occupies half the height of the screen. The second one occupies the other half of the height. Notice that the boxes are still 144 dp in terms of height because we have said 144 dp over here. Let's make the height take up as much space as available. Once I do that, notice that the green box stretches all the way to fill up all the available space in the linear layout horizontal which we have here. So we can do the same thing for the other child by saying match parent, and the red box also takes up all the available space. Now if you repeat the same step for the other two boxes, you will notice that all the 4 boxes now appear to divide the screen into 4 equal parts. Now this is not just on Nexus 6P. If you preview this on all the screen sizes, you will notice the same result everywhere regardless of the screen size. But remember that using weight inside weight is not such a great idea. If you go to Android Studio, it itself says here that nested weights are bad for performance if you hover your mouse over there. So we can achieve the same layout with other means, which we will take a look at in the upcoming videos. So hopefully you guys have understood something about layout weights in this video. Just remember one simple rule: if the orientation is vertical and if you put a layout weight on any of its children, then it applies to the height of that item. If the orientation is horizontal and if you put a layout weight on any of its children, then that weight applies to the width of the children, as the case is. So thanks for watching. I'll catch you guys in the next video. Have a nice day.